In today's video, we will consider refraction of light through a prism. What is refraction? When a ray of light passes obliquely from one transparent medium to another transparent medium, then it changes its path. This phenomena is known as refraction. For example, let us consider this black line is interface between air and glass. Upper medium we have taken air and lower medium we have taken glass, and this is ray of light that is falling obliquely. When it goes from air to glass, it moves towards the normal, because air is rarer medium, glass is denser medium. So when ray of light is going from rarer medium to denser medium, it changes its path and it moves towards the normal, and in this case angle of incidence will be greater than angle of refraction, or refracted angle will be less than angle of incidence. This particular diagram is representing entrance of a ray of light from rarer medium to denser medium. What happens when ray of light is going from denser to rarer? Now in this case, a ray of light is going from glass to air. So this is incident ray of light. This is a normal. Angle between normal and incident ray will be angle of incidence. When it goes from glass to air, then it moves away from normal. So this is a refracted ray, this one. And angle between refracted ray and normal will be known as angle of refraction. As a refracted ray is moving away from normal, so in this case angle of refraction will be greater than angle of incidence. This is oblique incidence, this is oblique incidence. In both these cases, ray of light is changing its path. What happens in this case? In this case, ray of light is falling normally, and when it is falling normally, for normal incidence there is no change in path. Angle of incidence is 0, angle of refraction is also going to be 0. This all we have done in previous part, that is light reflection and refraction. We have also studied that how ray of light is getting refracted when it is passing through a glass slab, and what happens to the path of ray of light when it passes through lens. Today we will consider refraction of ray of light when it is passing through prism. Now question is, what is prism? Prism is a wedge-shaped portion of a transparent refracting medium, bounded by two plane faces inclined to each other at a certain angle. This statement will be more clear to you when I will consider a particular shape. This is diagram of prism, and if I want to compare this diagram with a similar shape, then I will consider this shape, this particular shape. Now you do comparison, or you try to find out similarity between this shape and this shape. This particular shape has one rectangular face ADEB, so this can be this face, this one. And other rectangular face, it is going to have ADFC. This is this part, ADFC. AD is common in both this face and this face. These two faces are known as refracting faces. When I have kept prism like this, I can keep prism like this also. So in this case, this will be one refracting face, this will be another refracting face, and between these two faces I am going to have a certain angle. These two faces are inclined to each other with a certain angle. This particular angle will be known as angle of prism. And these two faces are known as refracting faces. Why? Because ray of light will enter from one face and then it will come out from other face. So refraction will take place. So this line AD, which is along the two refracting faces where they meet, this line will be known as a refracting edge. And if you will see this prism kept like this, and this side also you have paper, then one triangle you will be able to get here and one triangle you will be able to get here. So prism is having two triangular bases. One is this one and one is this one, and it will have three rectangular surfaces. How three rectangular surfaces? This is one surface, this is another surface, and if this part also you will have paper, then it will have three rectangular surface. One will be this, one will be this, and one is in front which is joining these two rectangular faces. So prism, when kept here, it is showing you two triangular bases, one this one and one this one, this triangular, and three rectangular faces, 1, 2, similarly third will be in front. So what is prism? Which consists of two triangular bases and three rectangular surfaces. The angle between two refracting faces will be known as angle of prism. Here we are going to have two refracting faces, ADEB and AB, and we are going to have ADEB, and another one we are going to have ACFD. Another one we are going to have ACFD. Two refracting faces of prism. One is this side, that is ADEB, and other one which we are going to have ACFD. Angle between these two faces will be known as angle of prism, and this line AD will be known as refracting edge. Now if this prism you are going to cut by a plane that is perpendicular to refracting edge, means like this you are going to, you have kept it like this and like this you are going to keep, then you will be able to get the shape of a triangle, and this triangle is known as a principal section. So any section of the prism that is cut by a plane perpendicular to refracting edge, means like this you have kept and then you are going to cut it. When you will cut it perpendicular to this, then you will be able to get a triangular shape. That will be known as principal section. So we are again doing the terms related with the prism. The prism is going to have two triangular bases and three rectangular surfaces. In this diagram, two refracting faces of prism are shown. One is going to be ADEB and other is going to be ACFD. The line AD along which these two refracting faces are going to meet, this will be known as refracting edge. And the third face BCFE, that is opposite to this refracting edge, is called base of prism. Angle between two refracting faces will be known as angle of prism, and any section of prism that you are going to cut by a plane perpendicular to refracting edge will be known as principal section of prism. Now we will consider how refraction of light takes place when it passes through prism. This ABC is showing the principal section of prism. So I am going to consider here one incident ray of light. This is one incident ray of light. If this prism will not be there, then this ray of light will go straight like this. But as prism is there, so here medium is air, here medium is glass. It means this ray of light is going to enter from rarer medium to denser medium. So at this point it will suffer refraction. And as it is going from rarer to denser medium, so it will bend towards the normal. If I will draw normal at this point, let me consider this is representing normal. So this ray of light will not go like this. It will move towards the normal, and when it will move towards the normal, it will come towards this normal. So let us consider this is going to deviate from its path. So this is going to be incident ray, this is going to be refracted ray, and this is a normal at this point. So at this point, path of ray of light is deviated by this angle. Now let us consider refraction at this face. When ray of light will fall at this point, now it will come out from glass to air. It means it is moving from denser to rarer medium. And when it will move from denser to rarer medium, it will move away from normal. So when it will move away from normal, I will draw one normal here. Let us consider this is normal. As this ray of light, in absence of this refracting surface, it should go like this. Now it will move away. Move away means it will come this side towards the base of the prism. So when it will move away, this will be the final path followed by a ray of light. So when refraction was taking place at this point, the path was deviated by this angle. When refraction is taking place at this point, the path is deviated by this angle. It means the ray of light, when it is falling on one face, it will get deviated through certain angle. Its path will change. It will have certain deviation from its path. So this we are going to consider in this diagram, how refraction of light is taking place when it is falling on face AB and when it is falling on face AC. First it will fall on AB. This is point of incidence. We have drawn normal. So when ray of light will go from rarer to denser medium, this ray of light will bend towards the normal. So this will be the path followed. And when it will fall on AC, again it will suffer refraction second time. So now it is going from glass to air. So in this case, it will not move straight. It will not move towards the normal. It will move away from the normal. So when it will move away from the normal, it will move like this and it will move towards the base of the prism. Now in next diagram, I will consider what do you understand by angle of deviation. In this diagram, I have considered this is incident ray. N1, N1 dash is normal at this point. On falling on face AB, this ray of light is suffering this much deviation. On falling on face AC, the ray of light is suffering this much deviation. So what is total deviation suffered by ray of light? For this, we will see the angle between emergent ray and incident ray. This is path followed by incident ray. In absence of this prism, this ray of light will go straight like this. This is actual path of incident ray. But when it is coming out through prism, it is following this path. It means this ray of light, which was supposed to go like this, it is changing its path. By how much angle it is going to change its path? To find that angle, we will produce this emergent ray in backward direction like this. And we will find this angle. Now this angle D is known as angle of deviation. What is angle of deviation? The angle by which the ray of light changes its path when it goes or when it suffers refraction through a prism. See, actually this angle will be sum of this angle and this angle. How? This angle and this angle, vertically opposite angles. And this is exterior angle. Exterior angle will be equal to sum of two interior opposite angle. So if I will consider this to be D1, this will become D2. This will also become D2. So angle of deviation D will be equal to D1 plus D2. So this diagram is representing how refraction is taking place at two faces. This diagram is representing angle of deviation mainly. How angle of deviation, total deviation will be equal to sum of deviation produced at one face and at another face. Now, on which factors this angle of deviation depends? It depends on angle of incidence. It depends on the material with which prism is made up of. It depends on wavelength of light used, which color you are using. Also, it depends on angle of prism. What is the angle between its two refracting faces? So all these factors are representing on which this angle of deviation will depend. Now this diagram was showing a refraction at two faces. This is mainly showing angle of deviation. This is complete diagram that is asked from you. Draw a labeled diagram to show refraction through a triangular glass prism. So this is the diagram. This is incident ray. This is normal. This is angle of incidence. This should be the actual path followed in absence of prism. But due to presence of prism, this will deviate from its path. It will move towards the normal. So this is angle of refraction R. It will suffer second refraction at this point. This is normal at this point. It will move away from normal as it is going from glass to air, as it is going from denser to rarer medium. The angle between normal and emergent ray, this is emergent ray, this will be known as angle of emergence. When you will produce this emergent ray in backward direction, then angle between the actual path of incident ray that it will follow in absence of prism and this backward produced emergent ray, this angle will give you angle of deviation. So I have shown here PE is representing incident ray, EF is representing refracted ray, FS is representing emergent ray, I angle of incidence, R angle of refraction, E angle of emergence and D angle of deviation. This is a labeled diagram. Practically you have to do it in lab. Now what is difference between refraction produced by a prism and a refraction produced through a glass slab? This is diagram that is representing refraction through a glass slab. In this case, incident ray is laterally shifted. In this case, both the faces, refracting faces in case of glass slab are parallel. So incident ray is laterally shifted. It means emergent ray and incident ray, they will be parallel to each other. So in this case, angle of deviation is coming out to be 0. But in this case, both these refracting faces are not parallel. They are inclined to certain angle. This shape of triangular prism will make the incident ray to get deviated by certain angle. So in this case, angle of deviation will be there. In this case, lateral displacement will be there. So what is the difference? Difference is due to difference in shape. Here refracting faces are parallel. Here refracting faces are inclined. So when a ray of light suffers refraction through a glass slab, the ray of light emerges in a direction parallel to incident ray on the slab. It means in glass slab, emergent ray and incident ray both will be parallel to each other. We will have lateral displacement. And in this case, we will have angular deviation we are going to have in this case. In slab, displacement is in length, means perpendicular distance I will measure, that will be 1 centimeter, 2 centimeter like this. It will be in terms of unit of length. And in this case, in prism, the ray of light deviates through a certain angle from its original path, which is known as angle of deviation, and this deviation will be measured in angle unit, means you are going to measure it in degree and here you are going to measure it in centimeter. One more difference is there related to dispersion that I will consider with you in next video. So you go through it, try to do questions and draw this diagram very carefully.